In this video, we are going to look at the carboxylic acids. Now, carboxylic acids are just the common name, but for us, if we want to use the organic name, these are known as alkanoics. Then the first step that we are going to look at the functional group. So the functional group for carboxylic acid is this, the Cu, which can also be represented as a structure where we have this C or then OC. Then from there we need to look at their names. So their names ends in ANOIC. So we have an anoics. We have methanoic, propanoic, ethanoic, butanoic, etc. Then we also have to look at the formula. So the formula is Cn H2n plus 1, then Cu. But this time the value of n starts from 0, 1, 2, 3, 4. So from the previous videos on organic chemistry, n was beginning from 1. So methane, we looked at methane at position number 1, but under carboxylic acid, it changes into position 0. So methane is 0, ethane goes into the position number 1, propane position number 2. So that is the pattern. Then the other characteristic or properties associated with these acids, they are weak acids. Then they also have, they taste sour, or they have a sour taste. Then they can also change or turn blue litmus paper red. Then they have the pH lower than 7. Then now from there, let's look at some of the examples. So we'll say write the molecular and structure formula of the following. So begin with the first one, methanoic acid. Then the second one, ethanoic. Then we have propanoic. Okay, so let's begin with methanoic. So first begin by writing the molecular formula. So the formula is Cn H2n plus 1. Then we have Cu. Now we say the under methanoic. So methanoic is 0. So the value of n is 0. So we can now put here, we have 0. Then 2 times 0 plus 1 COOH. So C times 0 is just 0. Then 2 times 0 is 0 plus 1. 0 plus 1 is 1. So the molecular formula for methanoic acid is this one. Now let's look at the structure. So the structure formula, first we need to draw the functional group. So this is our functional group. Then from this carbon, we can see that we already have 3 bonds. So we need only 1 extra bond where the hydrogen will be placed. So this is our structure. Let's look at the ethanoic. So begin with the formula. So this time F is on position number 1, so n is equal to 1. So C times 1 is C. 2 times 1 is just 2 plus 1. So then we have CH3. So this is the molecular formula for the ethanoic acid. So we can see that we have 2 carbons, so let us write 1, 2. Then the functional group should be only carbon number 1 always, so this is where our functional group will be written. Then we complete now the remaining structural formula. So this is the structure. Now let's try another one more for propanoic. Cn, 2n plus 1. So this time n is equal to 2, so where there is n we put 2. So C times 2 is C2. 2 times Z, this 2 will have 4 plus 1. Then our final answer is C2H5 Co. Then we said that the first step is we need to write the carbon, so we have 3 carbons in total. Then the functional group should be on carbon 1. Then we finish the remaining part of the structure. So our 5 hydrogen, we have 1, 2, 3, 4, 5. So this is how you can write the molecular and structural formula given the name of a molecule. Now from there, let's look at the formation of carboxylic acid. Now, formation of carboxylic acid, we'll just look at the hydrolysis of esters. So from the hydrolysis of esters, this is just the decomposition of reaction due to the addition of water. So what we are looking at here is, if for example we have an ester, then we add water, then the condition is we need to apply heat, and also we need to add a dilute sulfuric acid as our catalyst. Then the product is we are going to get alcohol. So we'll say we are going to get alkano plus the carboxylic acid, or we just say alkanoics. So the point here is whenever you add water to an ester in the presence of heat and sulfuric acid, this ester will decompose. Then after decomposing, we are going to get the alcohol and the alkanoics. Then the reverse of this process is called esterification. So if we add alkano plus the alkanoics, we get ester plus water. If we add water to an ester, you get the alkano and the alkanoics. So that is the key picture. Let's say, for instance, if we have an ester like methyl. So methyl ethanoate plus we add water in the presence of sulfuric acid and heat. So from this ester here, the methyl part indicates the alcohol that was used, so the alcohol was methanol plus then ethanoate indicates the acid that was used, so that was ethanoic acid. So this is what we call hydrolysis. So this is what we call hydrolysis. So we have formed the ethanoic acid from the hydrolysis of an ester. So this is one of the ways in which we can form the carboxylic acid. Maybe For more information and hydrolysis and esterification, we'll look at those into the next video, where we'll look at esters. Now, the other thing we can know about carboxylic acid are like chemical properties. So chemical properties, the first chemical properties, carboxylic acid, if you have a carboxylic acid plus you react it with a base, the products are salt and water. Let's use plus. So salt plus water. Then the second one, if we react carboxylic acid plus let's say metal carbonate, so we get salt plus water plus carbon dioxide. Okay, let's say, what if we react carboxylic acid plus a pure metal, we get salt plus hydrogen. Then another chemical property, what if we react a carboxylic acid plus alkano? This time we are going to get ester plus water. So these are some of the chemical properties of the carboxylic acids. Now let's look at the first one in terms of the chemical equation. So we say we have ethanoic acid, then reacting with sodium hydroxide. So this hydrogen here will be displaced by the sodium. Then we are going to have the product of sodium acetate plus H2O. If you look at the ionization of this ethanoic acid, if we have this ethanoic acid, then if we dissolve this in water, or we can say if we try to ionize it, we are going to have CH3, then COO minus plus positive hydrogen. So this, where there is minus, is where the sodium atom will attach or will be attracted by the force of attraction. So that is the picture under the chemical properties of carboxylic acid. So that's it for this video. I just wanted to give you a clue on carboxylic acid. So thanks for watching.